Imagine a world without electricity. People would still be dreaming about space travel instead of seeing it happen on television. Words like computer, air conditioner, and television would not be a part of our language. Electricity makes it all happen. Electricity is invisible, yet it's everywhere. But what do we really know about this invisible friend that lights cities, powers appliances, and fuels the brains of computers? That's why we're here. People do not fully understand the behavior and hazards of electricity, and every day they unknowingly involve themselves in injury-producing situations. Electrical safety is what this program is all about. And to help us understand a little more about our invisible friend, we've invited a visible friend, Tom Sterner, to talk about electrical safety.
We'd like to talk to you about how electricity works, and we're going to do it in a way we hope proves interesting. You won't be overloaded with a lot of technical terms and concepts, but by the time this program is finished, you'll have a pretty good understanding of the hazards and the safeguards of the electrical system in your home and at work. When we use the word hazard, how much electricity are we talking about? Just a little bit. In fact, the amount of electricity it takes to light this bulb can kill. The point to remember is a little bit of electricity can kill. We'd like to start at the beginning to help unravel the mystery of electricity that exists for many of us. To help make things clear, we're going to pay a visit to my old friend, light-hearted Lenny. This is Lenny's home, and this is where it starts. Electricity travels through power lines, which may either be above or below ground level. These lines enter your home through an electric meter. The electricity then moves to the fuse box or circuit breaker box. Why do we need fuses and circuit breakers? Well, simply put, if we try to force too much electricity through any size wire, such as when we hook too many appliances into one outlet, the wires can become hot and even catch fire. To prevent this from happening, fuses or circuit breakers have been placed in our electrical system to break the flow of electricity before the danger point is reached. Different size wires carry different amounts of electricity and therefore need different size fuses. Now, I know we promise to keep it simple, but there is one electrical term we're going to use, and that's ground. Simply put, ground is the earth, and electricity is always trying to find a path to it. We need ground to keep our electricity from wandering dangerously through our home or workplace. Electricity follows the easiest path ground whenever it has a chance. Electricity can travel through metal, the earth, wet objects, and anything with water in it. That could mean trees and other growing things, such animals and people. We send electricity through wires protected by insulating materials such as rubber and plastic. In your home, a separate ground wire from the fuse box should be connected to your water pipe, which itself is in contact with the earth. As a result, our faucets and radiator become part of our home's grounding system, since they are connected to the water pipes. As you see in this illustration, the electricity travels out of the fuse box to your outlet through this black wire. When an appliance is turned on, the electricity in the black wire flows through the motor and through the white neutral wire back to the outlet, then to the fuse box. We're going to use Lenny's drill to show you how electricity works. After the cord is plugged into the outlet and the switch is closed, electricity travels into the drill, through the motor, and then out, making it run. When the switch is open, the path is broken and stops electricity in its tracks. This is basically how all appliances run. Switch closed, the appliance runs. Switch open, no power. Now we're going to talk about a shortcut, which electricity sometimes takes when looking for the fastest way to get to ground. We call the shortcut a short circuit, and here's how it happens. Let's say that the insulation on the wires within the drill case breaks, and the wires inside touch against the metal case of the drill. the drill develops a short circuit, which means that instead of the electricity following the path that we spoke about a moment ago, some of the electricity gets sidetracked while looking for its way back to ground. In this instance, the metal case of the drill picks up some of that sidetracked electricity we talked about. As you see, the drill may still run fine, but the case is energized. The electricity looks for the fastest way to ground, which happens to be the faucet that Lighthearted Lenny is touching. This is because the faucet is connected to the water pipe that's part of our grounding system. And Lenny helped the electricity find its path to ground the hard way, ending up with a handful of electricity. As you see, some of the electricity is leaking through Lenny, and the rest is powering the drill. Now, if this drill had a UL label, that would mean that when it was made, it met certain safety requirements. But like anything else, after years of wear and tear, the drill can develop defects, such as frayed wires. Everyone has probably felt the tingling sensation from a tiny bit of electricity, and it didn't seem to hurt him. But Lighthearted Lenny can tell you that it doesn't take much to alter the rhythm of your heart or your breathing system. Now remember, we're talking about just a little bit of electricity. The electricity in your home can overpower the nervous system in your body. It only takes a little bit to do a lot of damage. An electrical shock can be so severe that you cannot let go of the appliance or wire. Such contact is painful and frightening. Keep in mind that your heart works on an electrical system of its own. And if the heart comes in contact with a jolt of electricity from outside the body, it can be fatal. To help avoid this shocking situation, a safeguard we are all familiar with was invented, the three-prong plug. Did you ever wonder why some plugs have 3 prongs and there are 3 hold outlets? Actually, what we've done is added another wire to provide a path to ground through it rather than Lenny. Let's add this third wire to our model and see how it works. Now, when we use a properly grounded tool or appliance, no electrical shock will occur. That's because the electricity that energizes the drill's case now travels safely back to ground through the third wire. It flows in such a large amount that it causes a fuse to blow or a circuit breaker trip, which indicates that the equipment you're using is electrically unsafe. Don't use the appliance or tool again until the defect is corrected. Now what happens? We have all these 3-prong plugs, but we live in a house with a bunch of 2-hold outlets. But wait, American ingenuity to the rescue. We present the 3-prong 2-hold adapter. And here's how it works. Take this 3-pronger here, and you plug it into the adapter, and then you plug it into the outlet. And what do you do with this little wire? It's the new ground wire we've been talking about. Well, you're supposed to hook it to the screw on the outlet cover. The only problem is that many of these screws aren't hooked to ground. So this adapter ends up defeating the purpose of the 3-prong plug. We won't tell you not to use these adapters since there are millions of 2-hold outlets. But be aware that if this little wire is connected to ground or the screw isn't grounded, you don't have the protection from short circuits just discussed. I think I smell coffee. Let's go to the kitchen and see just how your electrical system really works. Yep, the coffee pot is plugged in, so is the toaster, and so is the iron. Notice where everything is plugged in. Convenient? Maybe. Good idea? I don't think so. We can show you what's wrong if we head on over to Lenny's kitchen. Just as I thought, Lenny's all ready for breakfast, and for ironing too. As you can see, Lenny's no stranger to American ingenuity either. He went down to the hardware store and brought back a whole armful of ingenuity with him. We have an adapter that screws into the light socket, and a gizmo that makes it possible to run nearly a half-dozen appliances all from the same outlet, where before there were just 2. Now we're going to turn on all Lenny's appliances and see what happens. Just as I thought, we've blown a fuse. What can we do to fix things? Some folks would put in a larger fuse. I can hear it now. If a smaller one can't do the job, I'm sure a larger fuse can. The only problem problem is that the wire leading to the outlet might not be able to handle this added electricity we're now sending through it. Remember, we said different size fuses allow different amounts of electricity to pass through them? What you're going to see is that this wire was not designed to handle additional electricity. Heat is building up in the wire behind the wall, which can cause a fire. This can also happen in the attic if the wires heat up and are lying against something that'll burn. If a fuse blows, replace it with the same size fuse. I'll bet you thought you were safe any time your toaster was not turned on. That may not be true. This is another typical electrical circuit that we talked about. Electricity comes in here through the black wire and out here. Switch on, toaster works. Switch off, no toast. System. Notice how the switch stops the electricity here before it gets into the toaster. Now we've unplugged the toaster to clean it, and when we plug it in, we reverse plug. Let's see what difference that makes. The black wire now leads directly to the heating element, bypassing the switch completely. The toaster's not heating up, but it's chock full of electricity just waiting for a path to ground. Everybody knows what it's like to try and fish out that crooked slice of toast, or those muffins that get jammed and won't pop up. We might want to stick a knife or fork in here. Don't do it. Instead, we'll get Lighthearted Lenny to show you what happened. Lenny is setting himself up as the fastest way to ground. But the system keeps getting better. Ta-da! The polarized plug. This is the plug that you've muttered about under your breath as you tried to plug it in. The one with the little doohickey that's probably caused you all kinds of problems. But it's there for a reason. The polarized plug makes us plug the appliance in the right way. We can't plug it in backwards. If our toaster has a polarized plug, we avoid the possibility of crossing the wires, which eliminates the shock hazard. See, polarized plugs really do have a purpose. Remember, always unplug an appliance first if you're going to clean or work on it. Let's head upstairs to the bathroom, where we'll see yet another improvement to our electrical system. The double insulated appliance. Ever hear that term? It means that the case of this hairdryer is made of what we call a non-conductive material, like plastic. Electricity can't travel through it, so even if we have a problem, like saw with the drill, the stray electricity in the hairdryer can't get out through the plastic case. Appliances that produce heat, such as hairdryers, hot curlers, and curling irons, need lots of electricity. In fact, there's enough electricity here to overload this outlet. Good. The system is working. We blew a fuse again. Look over there. Extension cords. We call them convenient culprits since they're so easy to misuse. Extension cords often have instructions printed on the wrapper when you bring them home from the store. And we all know where that wrapper ends up. And then what do people do with extension cords? You've got it, out of sight and out of mind. They tuck them under the rug and they end up under the rocker. Out of sight? Maybe. A fire hazard? Definitely. And look here. Light-duty extension cords, I'm sure, can't carry the load. And if we look outside, we'll see another bad situation. One that can be fatal. Wet car, wet driveway, and wet feet. A very dangerous combination when a vacuum cleaner is plugged in, especially if we don't have the most recent innovation, GFI, in our electrical system. Now, GFI is a great family invention. It's also known as a ground fault interrupter. That's what these strange-looking outlets with the funny little buttons are. Remember, we said electricity can leak out looking for a path to ground. Ground fault interrupters can detect tiny amounts of this leaking electricity and will shut the power off faster than you can say GFI. It interrupts the flow of electricity before it can hurt you. Now, you should never vacuum your car on a wet driveway in your bare feet, even with a GFI. In fact, the only reason our friends survive this dangerous situation is because of the GFI, the most effective electrical shock protection ever made. All right, let's stand back and see what we've learned so far. Well, we have a better understanding of how our electrical system works. And we know that electricity is always trying to find the shortest path to ground, and major appliances, such as refrigerators and washers, usually have three-pronged plugs and should have their own properly grounded outlets. If you aren't sure if your outlets are grounded, first have them checked by a qualified electrician. If anything seems wrong with an appliance, or if it gives even the slightest shock, spark, or if it stalls, be sure to disconnect the appliance and call for service. Always be sure to use the proper size fuse, or your wiring may overheat and cause a fire. A 15 amp fuse is normal for general household circuits. Larger fuses are used for major appliances which have heavy-duty wiring. Don't use electrical appliances or tools while in bare feet or when standing on wet grass or wet driveways. And remember, electricity needs our help to become harmful. People that misuse the system usually cause their problems, think that it can happen to them. Electricity is there when we need it to light our homes, cook our meals, and provide the power that we need for both work and recreation. Electricity helps us in many ways, but it needs to be handled safely. We should never try to bypass or eliminate safety devices, as they have been designed for our protection. Electricity truly is our invisible friend.